So we're going to look at the tangent function a little bit more in depth in terms of its properties. So here's the picture of tangent. Take a look at the asymptotes where they occur. So one way to describe the domain, because it's too difficult and it's impossible to list all the intervals where the function exists, the more common way is it's going to be the set of all numbers other than where the function doesn't exist. So the function will have vertical asymptotes at plus or minus pi over 2, 3 pi over 2, 5 pi over 2, etc. And one way to remember where those take place is to know that that's where cosine is 0. So at those input values, cosine is 0, which is why tangent as a function doesn't exist there. The range is negative infinity to infinity. The period is pi. And the x-intercepts occur where sine is 0. So these are just a couple quick ways to, just for reference, know where tangent will have asymptotes and intercepts. Cotangent, you can think of very similarly. So cotangent will have vertical asymptotes and values where the function doesn't exist. So domain restrictions where sine is 0. So wherever sine is 0, the function will have a vertical asymptote. The period will also be pi, and the x-intercepts will occur where cosine is 0. So you can take a look at tangent and cotangent, right above each other, and you could see they have very similar shapes and very similar domains, just in different places the function doesn't exist. And that's because one function's sine over cosine and one's cosine over sine. And then in terms of cosecant as a function, cosecant will have vertical asymptotes and be undefined, where sine is 0. The range, instead of being negative infinity to infinity, you can see the range would be everything below negative 1. Those are those U-shaped portions below the x-axis, and then everything from 1 to infinity, and nothing in between. The period will be 2 pi. And if I draw just a quick sine function on the same grid as my cosecant function, you can see where the x-intercepts are is where cosecant has a vertical asymptote, and where the minimums and maximums of sine occur, then that's where cosecant will share that point, because the reciprocal of 1 is 1, and they'll make those U-shaped portions kind of above and below the x-axis. Cosecant, unless it's shifted up or down, won't touch the x-axis or the y-axis, so there aren't any asymptotes, and the amplitude is, like I said in the warm-up, undefined because technically it doesn't reach a maximum or minimum value. And then secant will be very similar in that where cosine is 0, that's where the function doesn't exist, so asymptotes will be there. The range is the same as secant, and the period is also 2 pi. This one does, however, secant does, however, have one y-intercept, which is at 0, 1, because cosine touches the y-axis at 0, 1. But in terms of x-intercepts, unless we shift the graph up or down, this function won't touch the x-axis. So those are the 4 major shapes and all the properties there. That's cut into one spot just so we can have those. You can have those as a reference. But wanted to give you a little explanation as to why they look the way they do. If I draw a cosine function on the same grid as the secant function, you can see it follows the same properties as the sine and cosecant relationship. Where x-intercepts of cosine are, there's asymptotes, and where the minimum and maximums occur, they share those values. And then taking a look at a specific example, so if I want to graph 2 tangent of pi x, the way you'd find the period is much like you would with sine and cosine. You take what the period is and divide it by the coefficient of x. So in this case, the period of tangent is pi. So I take pi over, and the coefficient of x is pi, which means the period is 1. So if I want to think about how to break up my x-axis, I could put 4 marks and call that 1, put 4 marks and call that 2. So if I want to graph 2 periods, I can do that. The only difference, though, however, is tangent is actually goes through the origin, and is actually one period is actually centered on the origin. So what I'm actually going to do is think about between -1/2 and 1/2, there's going to be vertical asymptotes at both of those x values, and at 3/2, there's going to be a vertical asymptote. So that between -1/2 and 1/2 will actually be my first period of tangent that I'm going to sketch. You don't have to. You can start at 0. The only problem, though, is this function is not being shifted left or right, so tangent will go through the origin, but if you start at 0, you only have kind of half of that tangent shape, so that's why I put my first period centered over the y-axis. That way I'd be able to kind of sketch what tangent looks like. Now, in terms of the shape, you could, plot a bunch of values, or pick a bunch of values, make a table, and plot them. The only problem with that is it's going to take forever. So instead, if I know the general shape of tangent, and then know that it's centered on the origin because I haven't shifted left and right, the tangent of 0 is 0, and then tangent of 1/4, which is that first tick mark to the right of the y-axis, is usually 1, but that 2 is going to stretch my graph out vertically. Now, it's not specifically the amplitude, but it will stretch my graph to a y value of 2 at that first tick mark rather than a y value of 1 like in the warm-up when we did before. And the same thing will happen at -1/4. So the function will still look like tangent, but that's a vertically stretched version of tangent because that 2 out front is going to affect that. So there's one period of my 2 tangent of pi x function, and then between 1/2 and 3/2, it'll actually follow a very similar shape, just in a different location. So that would be my second period of tangent, would look like that. So 1 has a value of 0, and then we'll have that same tangent shape just stretched out a little bit because of that 2. And then in terms of identifying the intercepts and the asymptotes, if I want to identify the x-intercepts, that's going to be at 0, 0, and 1, 0. There's obviously infinitely many more intercepts, but I'm just going to identify the ones in my graph, my 2 periods of my graph. And then in terms of the vertical asymptotes, there will be vertical asymptotes at x equals 1/2, x equals 3/2, and also in my graph, x equals -1/2. Now, vertical asymptotes are lines, so you do have to specify x equals, because if you don't, then it's not technically a line, and if you call it y equals, then you're identifying a horizontal line. So please be sure you're identifying your vertical asymptotes as vertical lines with x equals at those 3 x values. If I want to take a look at this function here, graph 1/2 cotangent of 2x, the way to find the period is to take pi, which is the period of cotangent, and divide by the coefficient, which is pi/2. So I'm going to put 4 tick marks along the x-axis, call the last one pi/2, and then put 4 more and call the last one pi. The reason I know I can do that is because cotangent is actually undefined at 0, typically, and then I can graph 2 full periods to the right of the x-axis without having to worry about going to the left at all, and I'll show you that here in a second. So instead of the vertical asymptote being at pi, which is typically the 1 period, that 2 is going to make my vertical asymptote at pi/2, and you can verify that. You put pi/2 in for x, and you get 2 times pi/2 is pi. Cotangent of pi is undefined, so that's why pi/2 gives you a value of undefined, which is a vertical asymptote, and there'll also be a vertical asymptote at pi. So I have kind of the setup I need here, and then if I know the shape of cotangent, that 1/2 out front is going to compress my graph vertically, so I'm going to make my y-axis, instead of being counting by ones, I'm actually going to count by halves here. So I can go up to 1, but know that half is really the value that I need. So in that first period, in the middle of the period is where cotangent is going to cross the x-axis, so at pi/4. And then to the left of that and to the right of that, cotangent is going to have you're typically going to have a value of 1 and -1, but because of that 1/2, it's going to have a y value of 1/2 and -1/2. So that the same shape will occur in that second period. So I have my 3 points that I had in my warm-up, very similar, in my vertical asymptote. So if I just connect them with this cotangent curved shape, that's my graph. That's 2 full periods of cotangent just by knowing the shape, general shape, and where the function generally does not exist. Will save you a bunch of time in terms of creating the graph. And then if I want to identify the x-intercepts, in my two periods that I have graphed, it's going to be pi over 4 is 0 and 3 pi over 4 is 0. And then the vertical asymptotes will be at x equals 0, x equals pi over 2, and x equals pi. So there's two periods of cotangent with an adjusted period, and then just some additional information identified for that function. If I want to graph negative cosecant of x over 2, the way we're going to do that is actually by graphing negative sine of x over 2. Because if I graph negative sine of x over 2, it'll give me basically the locations of all the things I need for cosecant. It'll tell me where to draw my vertical asymptotes, will tell me where to make my U-shaped portions of cosecant. So the period of negative sine of x over 2 is 4 pi, and the amplitude is 1. So I'm going to break up my x-axis according to my sine function. 4 marks will be 4 pi. Another 4 marks will be 8 pi. I'll break my y-axis up from 1 to negative 1. And I'm just going to sketch my sine function. I'm going to make it dotted in red here because it's not the function I want to graph, but it's the function that's going to lead me to the one that I want to graph. So there's my sine function. I did go down first because I had a negative coefficient up front. And now, in terms of how to graph this cosecant function, you could try and create a table and plot values, and you could do all that. But I promise it's probably going to be easier to draw this, sketch this sine function, or at least know what this sine function looks like, and from it, create your cosecant graph. So if I want to graph cosecant, wherever sine has an x-intercept, I'm going to draw a vertical asymptote. So I draw my vertical asymptotes in there for my first two periods. And then where sine has a minimum in that first section of the graph, cosecant will share that minimum value and then make that U-shaped portion below it. And then that'll actually occur for the rest of this sine graph. So I'm going to draw those pieces in. So those four pieces right there are my cosecant graph. And I really don't have to plot any points or check any values. You can. It might affect kind of how wide you make your U, but in reality, we're just rough sketching this by hand, so it's not going to be perfect. That's really sufficient enough to draw your cosecant graph. If I draw my sine graph with my amplitude and my period adjusted for the function, and then my cosecant graph is really just a consequence of that. It's a reciprocal of the values of sine, and there's my graph there in purple. So the vertical asymptotes occur where sine has x-intercepts, and the U-shaped portions occur where sine has its minimums or maximums. And then if I wanted to identify some information about this graph, say the intercepts and the asymptotes, there aren't any intercepts to speak of. This function is not going to touch the y-axis, and it's not going to touch the x-axis, so there aren't any. But it will have asymptotes at least in the two periods that I drew, at 0, 2 pi, 4 pi, 6 pi, and 8 pi. That last one there should be 8 pi. So there's 4 vertical asymptotes, 2 in each period. And if I drew more periods, then obviously I'd have more information to identify. But that's the shape of cosecant, just as a consequence of how I drew my sine graph. So if I want to draw another cosecant graph, I'm going to create the sine function, y equals 1/3 sine of pi x. The amplitude will be 1/3, and the period will be 2. 2 pi over pi is 2. So I'm going to break up my x-axis from 0 to 2 and 2 to 4. And then I'm going to sketch my quick sine function. So my amplitude's 1/3, so the highest y value sine will reach is 1/3 or negative 1/3. And then I'm just going to sketch in my sine function. So it will look like this. If I put it in, I'm going to make it dotted again because it's not actually the function I want to draw. So there's my sine function. And if I want to graph cosecant, I'm going to do the same thing I did in the last example, and that is where sine crosses the x-axis, I'm going to put a vertical asymptote. And where the minimums and maximums of sine occur, that's where these U-shaped parts of cosecant are going to exist. So I'm going to draw those in. So 2 periods of cosecant would look like that. So that red dotted sine graph is really going to be the major part that I want to identify, because from there's my cosecant graph and it's drawn. If I want to identify some information about it, still won't touch any axis, so no x or y intercept, but the vertical asymptotes will occur at 0, at x equals 0, x equals 1, 2, 3, 4, and my x-axis is not in terms of pi because there was a pi in the interior of the function. So that's that cosecant graph drawn right there, just based on the sine graph that accompanies it. Now in terms of secant, I'm going to do the same thing that I did with cosecant, and that is identify the appropriate cosine graph that will give me the information I need for the secant graph. So negative 2 cosine of x has an amplitude of 2 and a period of 2 pi. So I'm going to break up my y-axis from negative 2 to 2. And now the only thing that I'm not going to do is, if I were graphing just cosine, I'd probably put 2 at the very top and bottom of my y-axis. The only reason I'm not going to in this case is because my secant graph is actually going to be kind of those U-shaped parts above and below cosine. So if I make cosine all the way to the top and bottom, I really won't have room to draw my secant graph. So that's something to consider, is how you break up your y-axis. You also want to leave room to draw your reciprocal function, so that's why I didn't put 2 at the top and bottom. And then in terms of my x-axis, I'll go 0 to 2 pi, 2 pi to 4 pi with 4 marks in each period. And then I'm just going to sketch my cosine graph. So negative 2 cosine of x would look like this dotted red line, the dotted red function here. And then to create the secant function, once I've appropriately drawn my cosine function, is where there's an x-intercept for cosine, I'm going to put a vertical asymptote. So I'll put 4 vertical asymptotes here. And then where those minimums and maximums occur for my cosine graph, I'm going to draw my secant graph. So secant would look something like this. And I added a vertical asymptote to the left of 0 and to the right of 4 pi. So I've technically drawn more than 2 periods, but I just didn't like the way having half of my secant function drawn there looked. But again, if you're asked to draw 2 periods, you can go 0 to 4 pi, and that's technically 2 periods, and you wouldn't have to do anything to the left or right of that. But I personally wanted to add those. I just didn't want to leave those half pieces there. So there's my secant graph. And then in terms of what the intercepts and asymptotes are, this function won't touch the x-axis, but it will have a y-intercept at the same place cosine has a y-intercept, actually, which is 0, negative 2. And then the asymptotes will occur at x equals negative pi over 4, negative pi over 2, excuse me, because I drew that one in, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So that's where my vertical asymptotes occur, and that's where the cosine function crossed the x-axis. And the last example is another secant graph, but this one has a little bit more of a period adjustment and a vertical stretch. So just wanted to give you another example to look at. So the amplitude of this cosine graph, negative 2 cosine of pi over 3x, is 2, and the period is actually going to be 6. So 2 pi divided by pi over 3 is 6. So if I want to think about how I want to break up my x-axis, I'm going to go 4 lines to 6 and 4 lines to 12. Similarly, I would, even though my amplitude is 2, I'm not going to make 2 at the top and bottom of my y-axis because I still want to have room to draw my secant graph. And then I'm going to sketch my cosine graph. So negative 2 cosine of pi over 3x will be this red dotted function here. So I'm going to draw that cosine function in. And then if I want to draw my accompanying secant function, wherever this cosine graph touches the x-axis, I'm going to put a vertical asymptote. So I'm going to draw my vertical asymptotes in. And then, using the shape of the cosine graph, I'm going to draw my secant graph. So where this function has a minimum or maximum, that's where the U-shaped pieces of secant will exist. So I will draw those in. And again, I added one asymptote to the left of 0 and one to the right of 12 pi, just so I can finish those 2 U-shaped portions. And that's my negative 2 secant of pi x over 3 from my cosine graph. So drawing your cosine graph and adjusting your period is what we did in sections 8.2 and 8.3. So it's not a stretch there to do that, but being able to draw the cosine graph is really going to be super helpful in drawing the secant graph that accompanies it. And then if I want to identify the information about it, the y-intercept will be 0, -2 again in this case, and the asymptotes will be at -3 halves, 3 halves, 9 halves, 15 halves, 21 halves, because if that's the only thing is breaking up 6 into 4 equal increments. That means that first tick mark is 1.5 or 3 halves. So that's the only kind of tricky part about identifying that, is please make sure you look carefully at where your asymptotes occur. I've seen people call that 1, call it 2, just not careful with what they're counting by. You could put those as decimals too, since they are exact values. I'm always going to go fractions, but that's your secant graph from your cosine graph. And that's how we're going to approach that to start. The next part of this section is taking these secant, cosecant, tangent, cotangent graphs and shifting them left and right. So it'll be a similar process, just moving them left and right in addition to being able to sketch their general shapes.